Let's begin our journey to master Cramer's rule with clarity. These are the topics that we are going to cover under the Cramer's rule. First one is we will learn what is Cramer's rule. In that we will understand why this method is named as Cramer's rule. Then we will derive Cramer's rule just to get a basic understanding of how the Cramer's rule was formed. Then we will extend this logic to find out how the Cramer's rule is applied for simultaneous equations or linear equations in three variables. Then we will also learn how to apply this Cramer's rule using these examples. Then I have some practice questions for you that you have to answer in the comment box. The correct answers will be given hearts. And then this video will be concluded. So here we begin our journey to learn Cramer's rule. This person you can see on your screen is known as Gabriel Cramer. He was born on 31st July 1704 and he died on 4th January 1752. He was a Swiss mathematician who was born in Geneva. Since childhood, he was very well versed with mathematics. At the age of 18, he got doctorate. Then he became professor in Geneva. What he did, he discovered an easy to solve method for simultaneous equations, which was consuming very less space. And the concept of determinants was used in his method. Therefore, this method was named after Gabriel Cramer as Cramer's rule. It is also known as determinants method because it was using determinants. So this is about Gabriel Cramer, who invented Cramer's rule. Now we will learn derivation of this Cramer's rule. So this derivation is very simple derivation. It is using elimination method to find out the values of x and y. Using elimination method, it is using determinants to find the value of x and y. Now how it is happening, we will learn here. To derive the Cramer's rule, we will first assume linear equations in two variables and then use simple elimination method to find out the values of x and y. So here are these two linear equations. First one is a1x plus b1y is equal to c1, which is equation 1, and a2x plus b2y is equal to c2, which is equation number 2. And we know that here x and y are variables and a1 a2 b1 b2 c1 c2 are real numbers. Then here an important condition, a1 into b2 minus a2 into b1 is not equal to 0. Now we will solve this by using elimination method. We have to eliminate first the y term. So what we have done, we have multiplied the equation 1 in previous slide with b2 and equation 2 with. Now why we have done this, you all know that we have to make this coefficient of y same. So we have multiplied equation 1 and equation 2 with these two real numbers. Now once we multiply, then we get this new equations. Then you all know that after writing those equations, we will subtract equation 2 from equation 1. So after subtracting, what we will get, plus b1 b2y and minus b1 b2y will get cancelled. And then what will be remaining? This term b2 a1 minus b1 a2 into x is equal to b2 c1 minus b1 c2. Then after shifting this entire term to right side, then what we will get? It will divide this entire term. So in this way we will get the value of x, which is equal to b2 c1 minus b1 c2 divided by b2 a1 minus b1 a2. I will name this as equation 3. Then similarly, we can find the value of y, which is equal to a1c2 minus a2c1 divided by b2a1 minus b1a2. And I will name this as equation number 4. Here it is, equation number 4. Now, once I get the value of x and y, then our next focus will be how to write this in determinant form. So till here it was same as elimination method. Now we have to write these given values of x and y in form of determinants. Now how to write them? We will consider one by one. So first what we will consider? We will consider this numerator. Then we will consider this denominator. Now see here, the value of x and y has same denominator. How? See, this b2a1 minus b1a2 is denominator of the value of x, and the value of y has same determinant b2a1 minus b1a2. So first we will write down this b2a1 minus b1a2 in form of determinant. Then you can see that numerator of y is a1c2 minus a2c1. This is different, and numerator of the value of x is b2c1 minus b1c2. So we will write these three terms in form of determinants. How to write them? First, what I will do, suppose this is determinant d and I have the values a, b, c and d. So this is the determinant form. Here I will write its simplified form, that is a into d minus b into c. We can write this determinant as a, b, c and d. Why? Because it will give same result as this. How? Let me show you. See this, a into d and this c into b. What I will get? A into d minus b into c. Here you can see that values inside the determinant can be written in these two ways. Now in this case, the numerator of the values of x and y and their denominator, we are going to write it in form of determinants using this concept that we have learned. How we will be writing? Whatever the numerator and denominator we have, it is in the simplified form. So we will convert that simplified form in form of determinants. But there is a little restriction over it. What is the restriction? Let's learn that. Just now we have seen that how to write the determinant in its simplified form, that is a, b, c and d. So this is determinant and its simplified form is a into d and minus b into c. So this is the simplified form of this determinant. Now we have similar kind of simplified form b2a1 minus b1a2. Now we have to write this in form of determinant in this way. How to write it? Let's see. This is b2a1 minus b1a2. So now we have to write it in the simplified form. This a1 I will write it as first term. Then this b1 I will write it at this position. Then this a2 I will shift it under a1, and this b2 I will write it in the row of a2 over here. So in this way we have to write the determinant from the simplified form. Here you can see that this a1 is coefficient of x and b1 is coefficient of y, and this represent our equation number 1, that is a1x plus b1y is equal to c1. So this represents the first equation, and this a2 b2 represents the second equation. Now as you can see that we write equations in the horizontal form, therefore we have to write coefficient of x of second equation in first column and the coefficient of y in second column. So in this way we write the determinant from the simplified form. Now some students may argue that why can't we write a1, a2 and b1, b2? Because see, this a1 and b1 belong to same equation. Similarly, a2 and b2 belong to same equation. Therefore, we have to write a1, b1 in first row, because this equation we write, this is in the horizontal way. Therefore, the coefficients represents equation must always be written in horizontal way. So this is the correct way of writing the determinant and not this way. I hope this has given you clarity on how to write the determinants. Now similarly, this b2c1 minus b1c2, which is numerator of the value of x, this is its simplified form, and now we have to write it in the determinant form. So how to write it? Let me show you. Now here you can see that this is c1. Why we have written c1 in first row? Because this c1 is constant term of first equation, that is a1x plus b1y is equal to c1. Now this c1 belongs to first equation, therefore it is written in first row. This is the first row. Similarly, the c2, that is constant of second equation, is written in second row. This is our second equation, therefore it is written in second row. So in this way we have to write the determinant form. Now using similar technique, we will write determinant form of the next simplified term. So this is the simplified term a1c1 a1c2 minus a2c1. Now this is the numerator of the value of we have find out in equation number 4. Now we have to convert this in form of determinant. So how to convert it? See, this a1 will be written in this place, that is first row, and c1 will be written in first row but in second column. Why? We all know that a1 and c1 belong to same equation, therefore they will be written in first column. Similarly, this a2 and c2, this belongs to second equation. These coefficient belong to second equation, therefore they will be written in second row in this way. That is, second row first column will belong to a2 and second row second column will belong to c2. So in this way we will get the determinant dy. Let us understand the logic behind this determinant d, dx and dy. So this determinant d represents the value of variables, that is a1 b1 and a2 b2. See over here, this is a1 b1 and this is a2 and b2. So the determinant d represents the value of coefficients of x and y. This is the logic behind this determinant d. Now let us understand what is logic behind determinant dx. So for that we will go to the determinant d. Now here you can see that this a1 and a2, these are coefficients of x. In order to find this determinant dx, we have replaced the coefficients of x in determinant d with this constant value c1 c2 over here, and we have written this b1 and b2 as it is in the second column. So these together will form our determinant dx. I hope you have got the logic behind writing this determinant dx. In order to write determinant dy. What logic has been used? They have replaced this coefficient of y in determinant d with the constants c1 and c2, and the remaining coefficients of x is written as it is. Here you can see that. So this is the logic. I hope you have understood the logics of this d, dx and dy. When we put the value of these terms, which is d, dx and dy, in equation number 3 and 4, then what we will get? The value of x will come out to be x is equal to dx upon d, and the value of y will come out to be dy upon d. And the most important condition, in order to apply Cramer's rule, you have to first check d is not equal to 0 in those set of simultaneous equations. I hope you have understood the derivation and logic behind writing these determinants and finding the values of x and y. So here are the simultaneous equations with three variables. We all know that x, y and z are three variables and their coefficients a1, b1, c1, d1, a2, b2, c2, d2, and a3, b3, c3, and d3. These are all real numbers. And we have represented those equations as equation number 1, 2, and 3. Now, in order to write determinant D, we know the logic. What is that logic? We write coefficients of first equation in first row. So coefficient of first equations are, here you can see that coefficients of first equations are a1, b1, c1. So in this determinant, we will write those coefficients a1, b1, and c1. Then I will close the determinant. Similarly, our second equation has coefficients of x, y, and z as a2, b2, and c2. Similarly, coefficients of third equation are a3, b3, and c3. So in this way we have written the determinant D for simultaneous equations with three variables. Now we have to write determinant dx. We all know that the determinant dx is written by replacing the column of coefficients of x with constant. So the column of coefficients of x with constant in determinant D is this one. So I will replace that with the constants. So constant of first equation is d1, second one is d2, and third equation is d3. And remaining columns I will write it as it is. So b1, c1, b2, c2, and b3, c3. So this becomes determinant dx. In this we all know that we replace the coefficients of y in determinant d with constants, and remaining column we write it as it is. So a1, a2, and a3, this is coefficient of x. Coefficients of y will be replaced with constants, so d1, d2, and d3. Coefficients of z we will write it as it is, c1, c2, and c3, and I will close this determinant. So in this way we write the value of determinant dy. Now similarly, to write determinant dz, what I will do, I will replace the column of determinant d which has coefficients of z with constant. So the constant of first equation is d1, second is d2, and third is d3. And remaining coefficients of x and y, I will write it as it is from determinant d. So a1, a2, and a3, I will write it as it is. Similarly, b1, b2, and b3, I will write it as it is. So this will give me the determinant dz. Now we have written the value of x is equal to dx upon d. If you remember, in simultaneous equations with two variables as dx upon d. So similarly, here also we will write the value of x as dx upon d, value of y as dy upon d, and similarly the value of z will be dz upon d. And here also the condition of the value of d must not be equal to 0 will be applicable. So this is the important condition in order to apply the Cramer's rule. If d is equal to 0, then Cramer's rule will not be applicable. Now how to use Cramer's rule? First step is to write the equation in standard form. Then we have to find the value of determinant d, dx, dy and dz. And we should make sure that the determinant d is not equal to 0. Then we have to find the value of x, y and z using x is equal to dx upon d, y is equal to dy upon d, and z is equal to dz upon d. In this way we have to use the Cramer's rule. Now let us learn how to use it using example. So this is the example. 4x plus 3y is equal to 4. 6x plus 5y is equal to 8. So these are the simultaneous equations with variable x and y. As first step, we have to check whether these equations are in standard form or not. So yes, these are in standard form. So our first step is completed. Then we have to go for step number 2, d, dx and dy. So first we will find the value of d. So determinant d, we all know that the first row consists of coefficients of x and y from equation number 1. So this is equation 1 and this is equation 2. So the coefficient of y in equation number 1 is plus 3. So I will write this 4 and plus 3 in first row of determinant d. So this is 4 and this is plus 3. Similarly, I will write coefficient of x, that is 6, and coefficient of y, that is 5, which belongs to equation number 2 in second row. So this is coefficient of x and coefficient of y of second equation, which is written in second row. So in this way we write the value of determinant d. Now after solving this, the value of determinant d as 2. Now we will write the determinant dx. To write this determinant dx, we will go to determinant d. In this determinant d, what we do? We replace the coefficients of x of equation 1 and 2 with constants, that is 4 and 8. So this 4 and 6, which belongs to first column of determinant d, will be replaced with constants 4 and 8. And this remaining column 3 and 5, which belongs to coefficients of y of both the equations, will be written as it is. So after writing this determinant dx, we will simplify this in this way, and we will get the value of dx as minus 4. We will write determinant dy. This determinant dy is written using this our determinant d. To write determinant dy, we replace the coefficients of y from both the equations with the constants, that is 4 and 8. After replacing this column of coefficients of y with 4 and 8, we write the coefficients of x of determinant d as it is in determinant dy. So in this way we write the determinant dy. Then after writing this determinant, we solve it and obtain the value of dy, which comes out to be 8. Here you can see that the value of determinant d is not equal to 0. Therefore, the Cramer's rule is applicable. Therefore, the unique solution of these two equations exist, and it is found out using this formula. X is equal to dx upon d, which is equal to the value of dx is minus 4 and the value of d is 2. So after substituting this, 2 ones are 2 and 2 twos are 4. So what we get the value of x as minus 2. Similarly, we find the value of y. Y is given as dy upon d. Once we put the value of dy, which is 8, and the value of d, which is 2, then what we will get? 2 ones are 2, 2 twos are 4. So this 4 will be the final answer of y. X is equal to minus 2 and y is equal to 4 is our required answer. So we will write it in this way. X is equal to minus 2 and y is equal to 4 are the required solution of this given simultaneous equations using Cramer's rule. I hope this has given you complete understanding of this Cramer's rule. Now we will use Cramer's rule for solving these two equations. So I will mark this as equation number 1 and equation number 2 as these are already written in the standard form. So our first step has been completed. In second step, we write the determinants d, dx and dy as this is a simultaneous equations with two variables and solve them to find their respective values. So determinant d can be written as shown. See, this is 3 and minus 4. These are coefficients of x and y of equation number 1. Therefore, they are written in first row. Here you can see that this minus 4, it is written with its sign over here. So in this way, we have to pick up this entire number with its sign. Then we write the coefficient of x and y of second equation in second row. So after writing the coefficients of both the equations, we will solve this determinant and find the value of d in this way. Now this value of d comes out to be 25. Similarly, we will write determinant dx. Now we all know how to write determinant dx. To write this determinant dx, we replace the column of coefficients of indeterminate d with constants of both the equations. So the constant of first equation is 10. We write it over here in first row and first column. Similarly, we write the constant term of second equation in second row and first column. Then we write this column of coefficients of y as it is. Now once we obtain the determinant dx, we will find out the value of dx, which comes out to be 50. Then we write the determinant dy, which is formed by replacing the column of coefficients of y with constants. Here you can see that the coefficients of x is written as it is, and this coefficients of y is replaced with constant terms, that is 10 and 5 over here. You can see that. Now once we write this determinant dy, then after solving this, we get the value of dy to be minus 25. Now once we get the value of d, dx and dy, we find out the value of x and y. Also here you can see that the value of determinant d is not equal to 0. Therefore, the unique solution of these two simultaneous equations with two variables exist. Therefore, we will find it out. So x is equal to dx upon d. After substituting values of dx and d, we will get 50 upon 25. So 25 under 25, 25 is 50. So the value of x is 2, and the value of y can be found out as dy upon d is equal to, so the value of dy is minus 25 and the value of d is 25. So this 25 will get cancelled, and what will be remaining? This minus 1. So value of y is minus 1. Value of x is 2. Then our final answer will be x is equal to 2 and y is equal to minus 1. So in this way, we use Cramer's rule to find out solution of simultaneous equations with two variables. Now here is the practice questions that you have to answer. This is based on the concept that you have learned just now. After solving these questions, you have to write its answer in the comment box. Those who will give me correct answers, their answers will be given hearts in the comment box. Just understand how to use Cramer's rule for simultaneous equations with three variables. So these are the three simultaneous equations with three variables as you can see on your screen. Now we have to use Cramer's rule to solve them. First of all, we will check whether they are written in standard form or not. Here you can see that they all are written in standard form. I will denote this as equation 1, equation 2 and equation 3. Then in second step we will write the determinant d, dx, dy and dz. Determinant d is written as, the logic for writing determinant d is we write all coefficients of x, y and z of each equation in respective rows. So first row will comprise of the coefficient of equation number 1, which is this. So coefficient of equation 1 are coefficient of x is 1, coefficient of y is minus 1 and coefficient of z is plus 1. Similarly, we will write the coefficients of x, y and z for equation number 2. So coefficients of x, y and z for equation 2 are x is 2, y is plus 1 and z is minus 1. So 2 plus 1 minus 1. Similarly, we will write coefficients of x, y and z for equation number 3 in third row. So coefficient of x is 4, y is plus 2 and z is minus 3. Now we will solve this determinant d. This entire term will be 0. What I will get? So the value of d will be minus 3. Now we will find the value of dx. In order to find the value of dx, we replace the column of coefficients of x in determinant d with the respective constants. So after replacing this, what we will get? Constant of first equation is 2, second is 1 and third is minus 1. So I will write it as 2 for row number 1, 1 for row number 2 and minus 1 for row number 3. And then coefficients of y and z will be written as it is. Y are minus 1, 1 and 2. Coefficients of z are 1, minus 1 and minus 3. So minus 6 plus 3 will give me the value of dx as minus 3. So in this way we have find out the value of dx. Now we will find the value of dy. So dy will be written, column of coefficients of y will be replaced with constants as we have replaced column of constants of x in dx. Similarly we will do for dy. Column of coefficients of x will be written as it is 1, 2, 4. Column of coefficients of y will be replaced with constants of respective equations, that is 2, 1 and minus 1. Similarly, coefficients of z will be written as it is. So 1, minus 1 and minus 3. And on solving this, what I will get? So minus 4 plus 4 will get cancelled. Then I will get the value of dy as minus 6. In this way, we have got the value of dy. Now we will find out the value of dz. To write the determinant of dz, the column of coefficients of z will be replaced with constants of respective equations. The column of z will be written as 2, 1, minus 1. Column of coefficients of y will be minus 1, plus 1, plus 2. And coefficients of x will be written as it is 1, 2, and 4. After solving them, now these together will give me the value of dz as minus 9. So we have the value of d as minus 3, dx as minus 3, dy as minus 6, and dz as minus 9. Now what I will do, I will find the value of x, which is equal to dx upon d. So dx upon d will give me value of x. So value of dx is minus 3 and value of d is minus 3. So these minus 3 will get cancelled and I will be left with x is equal to 1. Similarly, I will find the value of y. Y is given as dy upon d is equal to value of dy is minus 6 and value of d is minus 3. So minus 3 ones are minus 3 and minus 3 twos are minus 6. Therefore, value of y is equal to 2. Now I will find the value of z, which is equal to dz upon d. So value of dz is minus 9 upon value of d is minus 3. So minus 3 ones are minus 3 and minus 3 threes are minus 9. So value of z will come out to be 3. Therefore, z is equal to 3. So the final answer will be x is equal to 1, y is equal to 2, and z is equal to 3. I hope you have understood how to apply Cramer's rule for simultaneous equations with 3 variables. Now to validate your understanding, you can solve this question and answer in the comment box. All those correct answers will get hearts.
Got clarity on Cramer's rule? Awesome! If this video helped you, please consider supporting my efforts with like, subscribe and sharing with your friends. Your donations, big or small, even just 10 rupees, 20 rupees or 25 rupees or whatever you can spare on my Google Pay ID, directly fuel new videos and better content for you. It's how we build this learning community together. For donations, use Google Pay ID on your screen. And let me know the next topic in the comments you want me to give you clarity. Thanks for everything.